Have you ever seen an atom? Seeing as everything's made of them, you have, but have you ever seen one on its own? Over time, microscopes have become more and more powerful, allowing us to see deeper into the world of the ultra-small. Traditional light microscopes can be used to see things like these onion cells and the structures within them as they divide, pulling apart their chromosomes. But scientists have come up with a whole host of clever methods to observe far smaller things. Using beams of electrons instead of light, we can generate detailed images of chromosomes themselves. Recently, groups of scientists around the world are becoming able to see materials at the most fundamental scale, the atomic. One group from the University of California in Los Angeles have been getting up close and personal with nanoparticles of platinum, just a few nanometers across. Each of the tiny dots you can see here are actually individual platinum atoms. But researchers didn't stop at a two-dimensional picture. By imaging over 100 slices of the nanoparticle at different angles, then removing the noise with a special filter, they were able to map the location of almost every atom. The information was used to create a three-dimensional reconstruction of the whole particle in unprecedented detail. It may look blurry, but this particle is estimated to contain over 27,000 atoms, and so, like flies in a swarm, they appear to merge together. Every so often, though, we see the platinum's atomic structure align, granting us a moment of clarity. This technique is being used to analyze tiny irregularities in the structure of the particle called dislocations. Dislocations are subtle, like the misalignment of the green and red layers of atoms in this particle. But nonetheless, they can significantly change the properties of materials, with effects ranging from a change in the efficiency of LEDs to the strength of metal alloys. Three-dimensional atomic-scale imaging like this is bettering our understanding of the structure of materials on this truly fundamental scale.
Hi, I'm Emerald Robinson. In this What Is video, we're going to take a closer look at atoms. All matter is made of elements, substances that cannot be broken down by chemical activity. An atom is the smallest particle of an element that retains the element's properties. Atoms are the building blocks for everything in the universe, including ourselves. People often think of atoms as the smallest possible forms of matter, but even smaller particles make up atoms. Each atom has a dense center called a nucleus. The nucleus contains neutrons, which have a neutral electric charge, and protons, which are positively charged. The number of protons in an atom determines an element's physical properties. No two elements have the same number of protons. Revolving around the nucleus like planets around the sun are negatively charged particles called electrons. Electrons and protons attract each other, so atoms usually have equal numbers of the two particles. Scientists assign atoms an atomic number and atomic mass unit. The atomic number is the number of protons present in the atom. For instance, a helium atom has 2 protons, so helium's atomic number is 2. Add the number of protons and neutrons in an atom's nucleus together, and you get the atomic mass unit, or AMU. A helium atom has 2 protons and 2 neutrons, so has a mass of 4 AMU. Electrons have almost no mass and are not included in AMU calculations. While an atom's number of protons remains constant, individual atoms can lose or gain electrons. Atoms with different ratios of electrons to protons are called ions. Atoms of the same element can also have extra neutrons. Scientists call atoms with extra neutrons isotopes. Despite having different neutron counts, isotopes retain their element's chemical properties because the number of protons remains constant.
For thousands of how-to and advice videos on any topic, visit monkeysea.com.
Atoms are the fundamental unit of matter. They're made up of 3 types of subatomic particles: protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge. Protons and neutrons are located in the nucleus at the center of the atom, while the electrons orbit the nucleus. Let's take a quick look at an atom of carbon. Notice how the 6 protons and 6 neutrons reside inside the nucleus, while the electrons are shown in orbits surrounding the nucleus. The number of protons identifies the element. All carbon has 6 protons and therefore 6 electrons. However, there may be minor variations in the number of neutrons in atoms of an element. These variations are called isotopes. It's a little difficult to show the exact location of an electron. This is because electrons have almost no mass and orbit the nucleus of the atom at incredible speeds. Therefore, their precise location at any given moment can't be determined. For this reason, electrons are often shown as a negatively charged cloud around the nucleus. However, other diagrams show the electrons as existing in rings or orbitals. Orbitals are often used to illustrate the number of electrons at different energy states surrounding the nucleus. This is important because only the electrons at the highest energy states, or outermost orbital, participate in chemical reactions. These are called valence electrons, and they are involved in the formation of chemical bonds between atoms.
Atoms make up everything that we see on Earth, and they are the smallest components of matter. A diagram of an atom is shown here. The center of the atom is called the nucleus, which is made up of particles called protons and neutrons, the protons being red and the neutrons being yellow. Protons have a positive charge, and neutrons have no charge. The nucleus contains almost all of the mass of the atom, and therefore most of the atom's weight is located in its center. Surrounding the nucleus are electron orbitals. The diagram here is used as a way to represent the electron orbitals, with a certain number of electrons sitting on each orbital. The electrons have a negative charge and have an extremely light mass compared to the rest of the atom. So what is an element? Well, an element is made up from atoms. For example, copper is an element that is made up of copper atoms. Now on the left is a representative of the copper atom, and many atoms just like this combine together to form the copper element, which is located on the right. And this is how we would find copper in nature. So in summary, atoms are just really small particles made up of protons, neutrons, and electrons. And like atoms come together to make up elements. And elements are just a form of something as we would find it in nature. And as we'll find out later, it actually comes down to the amount of protons, neutrons, and electrons that determine what kind of element the atom will form.